Welcome to Chapter 18, Forecasting. At the start of our course, in first lecture, we learned that a business success involves a clever integration of a great operations-related strategy and the processes that can deliver the products and services and analytics that support the ongoing decisions needed to manage the firm. So far we have covered the strategy, we've also covered the processes. Now it's time to go deeper into analytics. So what the very definition of analytics is: identification of patterns from data. And one of the identification of patterns could be related to our demand, what our business faces, the demand of our product, the demand of our services. So the focus of this chapter would be forecasting for demand planning. If we recall, remember, our processes could be of different type to make our product or our service as well. Could be make to order, assemble to order, or make to stock. What determines which type of process should we be choosing is actually demand. We could see that on the left hand side. This is a figure from our earlier lectures. So not only the process, the type of supply chain that we should be using for a particular product and this right strategy is also dependent upon the demand that our product faces. So here we see based on the demand characteristics, our product would be functional and innovative, that we covered last week. So how could we predict our future demand? Through that will be with the help of a forecast. So what a forecast is, that it's a statement about the future value of a variable of interest. That variable of interest could be weather, could be victory of a soccer team, could be anything, but in our case it would be the forecast for future demand. We'll be going through this whole lecture through a case that is the prerequisite reading for this particular lecture. I hope you have gone through it. If you haven't, it's highly advisable that you go back and read it. As explained earlier, this is a very important chapter for your final exam, so I want you to really understand these concepts. So please go back and read that, and I would also advise you to take out a pen and a paper and start solving the exercise as I'm going through my slides. So I'll go through what the case said. It was about a flower selling business. So what they were doing was that they were not using any formal forecasting techniques for demand. So what the manager was doing, based on his experience and his instincts, he was deciding how many flowers he needs to buy and how many flowers he needs to send it to its customers. What the end result was that at certain occasions he had more stock. So because of the perishable nature of flowers, so he had more stocks and there were less buyers, so these flowers would go stale. But on certain occasions he was out of stock as well, so the customers would require the flowers and we wouldn't have any flowers to sell those to them. So that was also creating tensions. The result was, without a formal forecasting, demand forecasting and planning activities, he was having problems. So what he thought was that he should introduce formal forecasting procedures for two of his products. So the starting point was that he gathered the historic sales data for the two products for which he wanted to predict the forecast for week 15. So for 14 weeks he collected data for lilies and roses, and the aim was to predict the forecast for the 15th week for lilies and roses. So what now I've done is that I've plotted this data into an Excel sheet. The first thing we'll be focusing on is identifying any patterns from this data of 14 weeks, the historic sales data. First thing we'll do is that we'll plot it on a XY graph, where Y is the sales, historic sales, and X axis is the weeks. So here we have got weeks and we have got the actual sales, the quantity. So what we are seeing here is this is sales of lilies, and this is sales of roses. The roses sales is pretty steady, but every now and then we see a seasonal peak, then it goes down, then a peak again, then goes down, then a peak. So there is sort of seasonal variations, and there appears to be an increase overall. The general trend also seems to be increasing. So what I could do with the help of Excel is click here and then right click, appears menu, you select a trend line. So what this is explaining is that the overall trend for the sales of roses is little bit on the increasing side. So it was 40 to start with, and by the end of 14 weeks it was higher than 40. But apart from this general trend line, we also see a seasonal variation. So two of the components that we have identified from the historic demand pattern for roses is a general trend line, and the second one is a seasonal or a variation after every 4 weeks, then perhaps another 8 weeks. After 12 weeks we see a peak, then a little bit of down, and then again. So A, there is a general trend to it, B is the seasonal variation, and the third element which we could think of being a component of historic sales data or historic demand data is an average. So there will be an average of all these 14 weeks. So namely, there are three components of demand trend. Then we've got the seasonal variations that repeat after a fixed interval, and the third one is an average demand. So we could do the same to lilies as well. So we have fit in a trend line. The variations do not seem to be seasonal variations do not seem to be of having much impact here, but we do see an exception here for week 7, where the sales exceeded the average because of the Mother's Day. So learning is that there could be three components of historic sales data. So that tells us maybe a seasonal component, a general trend which may go up or which may go down as well, but in our cases both the trend lines are increasing. In case of lilies, the increase is quite high, but in terms of roses it's pretty steady, but there is some increase in general increasing trend. And third one is the average demand over this entire duration. Your book also mentions 2-3 other components of demand that we are not focusing in. We are just focusing on trend line, a seasonal component, and an average over this entire duration. What is the advantage of fixing in the trend line here? So all we are interested in is to identify any pattern from the historic data and may be able to predict our future event or future demand for week 15. In this case we have got week 14, we'll be predicting for week 15. So once we establish a relationship between the historic data, that's easier to predict. That will help us to predict our sales for week 15. Once we have fit in a trend line, the advantage of this one is we know the mathematics of this line. So if we right click here and go to format trend line, it says display equation on chart. So if I click on that, all it's telling me is that this equation, this linear equation, has an equation that is being represented by 3.4571 x plus 48.286. So this is the relationship between the y-axis, that is the quantity demanded, and the time. Based on this, we could be able to predict for future. So that is the advantage of fixing trend lines. There could be different trend lines. There could be linear trend line, which is in this case. There could be other trend lines as well that you could see in your slides. Could be S-curve trend, could be an exponential trend, but we'll be focusing on the linear trend line. One more thing before we go further is, if we see the y-axis is the quantity demanded, the x-axis is the time. So this is called a time series forecast. So time series is a time ordered sequence of observations taken at regular time intervals. So any past data that is plotted against time would be a time series. Next point of interest here is, our aim is to predict sales for week 15. So what are we likely to what sort of orders we are likely to receive on week 15? The easiest way could be based on this one. So we see an increasing trend, we see a trend. The best thing would be select whatever is the last value. So week 14 we had 96 orders for lilies and 44 orders for roses. The easiest, perhaps bit crude, is that we could take the last value that we face. So we are expecting week 15 forecast to be 96 and 44. That's the simplest of ways to predict about the demand for week 15. Another could be, instead of just taking the last one, we can take the average of the last 14 weeks. Let's take the average. And we can round it up. That could be 75, the same here. So based on taking an average of 14 weeks, we are getting we're predicting that in week 15 we would be receiving 75 quantity orders for lilies, and for roses we'll have almost 43, which is slightly different to the week 15 forecast. The idea is we could use different methods to predict about week 15. One was just taking the last value that we face. In this case for week 14 was 96 lilies and 44 roses. And the second is, instead of taking the last value, perhaps a more reasonable assumption could be that we take the average of all 14 weeks and average of all 14 weeks for roses as well. There could be another form of taking average of historic data. Instead of focusing on all the 14 weeks, we could choose 3 weeks, we could choose 4 weeks and take the average over these 4 weeks. So maybe if we are taking a 3 weeks average, it could be simply the last 3 value. So we'll sum up the last 3 value, 12, 13 and 14, divided by 3. So that will give us the average for the week 12, 13 and 14. The same we could do with roses. So we could have a 3 weeks average, we could have a 5 weeks average. So whatever we think or the manager thinks is appropriate and captures the situation more appropriately, we'll do that. Either 3 weeks, either 5 weeks, or the first one that we used was the last value forecasting method. Having learned to identify different components of demand, so that is trend line, seasonal variations and average demand, and also having learned 2 ways to predict week 15 forecast, that is the last value method and also the average method, we'll go to our lecture slides to reinforce what we have done so far. So any historic data that's plotted with time is called a time series data, and we learned that there could be 3 components of demand. So one is the general trend line, which could be increasing, which could be decreasing. Then we've got seasonal variation that repeats after every fixed interval, and then lastly we've got the average demand. So average of all this information would be, all this data would be an average demand. Then we learned what are the advantages of fitting in a trend, because we know the mathematics of the equation of the line. Based on that we'll be able to predict the future demand. The first method that we learned was last value forecasting method, which is the easiest of all. So whatever we faced in our last week or last year or last day, whatever was our last demand, we'll based on that we'll keep that value as our future demand, or likely demand that we'll be facing in the next period. So here we've got last 6 values for the last 6 months. So week 1, month 1 we had 17,000, then 25, 24, 26, 30. Last month we had 28,000. We took the same value for the 7 month. This is called last value method, and we're likely to face 28,000 demand for the for the month 7. That's the last value forecasting method. The second is a simple moving average. That's what we learned in our Excel. Just take the average of your past data. The term moving average means that instead of taking all historic data, you could choose the number of periods you would like to take the average of. So if it's last 6 months data, so 17, 25, 24, 26, 30, 28, from now onwards we'll say this actual sales. So T is the period that we want to predict for, so that's forecast for T period, and we've got all this historic data. So any data that's prior to time period T divided by the number of periods, we'll get the simple moving average formula. So again, so the same example, so we have got 6 values here, 17, 25, 24, 26, 30, 28 for the same example. So A6, the actual for the 6 sales for the 6 month was 28. Then similarly till A1, the actual sales for the first month, we divide by 6, we get 25. We could have taken 3 months as well. So for 3 months, we'll just take the 3 values, last 3 values, and divide by 3. Third one is third forecasting method is called weighted moving average, where you assign different weights according to what the management thinks, or you think that different periods have got different importance attached to them. So you reflect the relative importance by a weight. So here the formula is AT minus 1 is the actual sales for the 1 period prior, and we want to predict for the T time period, forecast for the T time period. And what we get here is that in this case we've got 5 periods. The actual demand or actual sales is this much, and we're being told that for each period, for the first period we have to multiply it with a 0.40 weight, and similarly so on. And if you multiply the respective weights with the historic demand, we get a forecast for the 6 month, which in this case is 41. A word about the choice of selecting weights. It's actually experience and trial and error. So you think that in your opinion this month's sales are more likely to affect the coming sales, so you assign it a higher weight. So it's just your business acumen, and that may be utilized to reflect the seasonal effects on the future sales. Last word about weighted moving average is that the sum of all these weights, 0.40, 0.30, 0.20 and 0.10, the sum of all these weights is 1 or 100% if you're talking in terms of percentages. So the sum of all weights should be 1. Now we'll move on to another forecasting method, and before we move on to the fourth one, so let's quickly have a recap. The weighted moving average, simple moving average, and the last value method. The problem with these forecasting methods is that they do not learn from past mistakes or errors or forecasting error. So what is a forecasting error? For example, here we had past data for 5 time periods, and then we were predicting for the 6th time period, that was a forecast. So our forecast that we are likely to receive 41 orders. But the 6th time period comes and we experience only 35 orders. So we predicted, forecast was 41, the actual orders were 35. So our forecast error would be 41 minus 35. So in this case our forecasting error is 6. All the methods that we have covered so far do not learn from the forecasting errors. The next one is called exponential smoothing, which does learn from the forecasting error. So what we have here is the formula for the forecasting or exponential smoothing takes a term here where we are minusing the previous actual from the previous forecast. So in that case 35 minus 41 as the case that we, or the example we covered last time. So and then we add it to our forecast, the last forecast, and we saying that based on these two terms we'll have our next forecast. So let's have a example. So ft is the future time period that we want to predict. So that future forecast will be based on the last forecast plus the difference between the forecasting error of our last prediction. So that is last actual minus last forecast, and then we multiply a constant to it. So we sum it together. That will give us our forecast for the next time period. So let's do a small example. So alpha is used, or it's called a smoothing coefficient. So its value has to be between 0 to 1, as was the case with weights. Mostly it's a choice of the manager or the analyst or the person using this exponential smoothing technique. Experience and hit and trial that improves the accuracy of your forecast is generally, these are the methods to select an appropriate alpha or smoothing coefficient. So let's do an example. The last forecast was 1050 and the actual sales were 1000, so our forecast would be 50, forecast error would be 50. So what we do here is, so this is our last actual sales, we deduct the forecast for the last time period, so and then multiply an alpha, which in this case is given 0.05, so we get 2.5, and we deduct it from our last forecast. So because our forecast last time was more than the actual sales, so now this time it's going to deduct from our forecast. So next forecast would be on the lower side, so it brings down, it keeps the track of future prediction, and it tries to relate it to the last prediction error. So this is why this exponential smoothing forecast method is surprisingly accurate. Most of the short-term forecasting that you see in around you is based on this exponential smoothing forecasting method because of its accuracy and because it utilizes the forecasting error, which in this case was 50, and this forecasting error is used to correct the future forecast. We got another example. So we've got actual demand here, and this is the forecast. So the same formula, so we're predicting for the second time period, and the first forecast was 820. Because we don't have any forecast, so we'll take actual demand as the first forecast. So because 820 minus 820 is 0, so we'll take the 820 as the forecast, and actual demand was on the lesser side, 775, and based on that we could use the third time period as well, but here I've used the fourth one. Fourth one is the third forecast, which was 811. Alpha we use as 0.2. So actual sales for 3 was 811, 680, and the forecast was minus 811. So then based on this, the forecast is now 785. So it's correcting, it's sort of a correction. You could check out the formulas by yourself as well for the next two calculations. So the forecasting error multiplied by a smoothing coefficient, and then we add it to the last forecast, so that will give us the future forecast. So most used for all forecasting techniques, especially because it's more accurate because of the use of forecasting errors. Now, having learned four different types of forecasting methods, so which method should we choose? One is that, that's more accurate. That's the exponential smoothing one. The other factors we could take into account while deciding for a particular type of forecasting model would be the time horizon, the future outlook for how many weeks, how many months we want to predict, the previous data availability, the accuracy required, as I mentioned, and then of course the size of forecasting budget and the people who know some background of forecasting. Got a table here. The simple moving average. So if you've got 6 to 12 months of past data, so weekly data are often used and for short predictions. One thing is that it cannot successfully or accurately predict any data with trend or seasonality. Only stationary. Stationary is more the average data, which does not change over time. Weighted moving average, again, it is good for stationary, short term horizon. Third one is the exponential smoothing with trend. So simple exponential smoothing does not predict accurately the trend, the data with trend, but if we modify the original formula that we won't be focusing in this particular chapter, we'll just cover the basic exponential smoothing. So we are also the exponential smoothing can also predict, if with some modification, the data with some trend component. The last one is the linear regression. It's the only one of these techniques that we'll be covering in this chapter, which we haven't done so far, that can also predict the seasonality. But all the ones that we have covered so far do not predict seasonality component. Just basically stationary, but exponential smoothing may also predict with accuracy the trend component. Seasonality will have to go to linear regression. We'll cover linear regression in the next video. Thank you.